Good evening, Sir Lee, and anyone that is watching. My name is Conan, and this will be my CCA final evaluation in the 5th of October 2021. This video or this evaluation will be a bit different because it relies on Moodle to give me the question. You usually have it print out, but I exactly can't. I've already written down the question from 2 to 5 into the PowerPoint so you can understand it a bit simpler. As for number one, the question is given to me when I attempted the quiz, so I will be telling you the question through voice or by me talking to you. This presentation is also going to be a bit different because I will be relying heavily on the presentation that you see in front of you right now, as well as Desmos, because this particular video evaluation requires a lot of graphing. With that said, let's begin. So, the first one asks us to take the base function of fx, basically as you can see in front of you, and the equation that they give us from the base function in the quiz later on. The one that I got looks something like this. They ask us to take all the key transformation by the variables and tell us to explain on how we get them and what they do to the graph itself. Simply, by this we can get that a is equals to -1, k is equals to equals to 3, d is equals to -6, and c is equals to -5. Now, the explanation for how I get these numbers for each transformation variables is as follows. For a indicates the vertical stretch or compression of the graph. It also indicates the graph if it's going to be reflected to the x-axis or not. The variable a is located at the beginning of the equation or behind f. So in this case, the graph will be reflected on the x-axis. As for k, it indicates the horizontal stretch or compression of the graph. It also indicates if the graph is reflected on the y-axis or not. The variable k is located at x. Basically, it times x by a certain amount of number, and it directly affects the variable d. In this case, the graph will have a horizontal compression of 1/3. The variable d indicates the shift of either to the left or to the right of the graph. And since the variable d is affected by the variable of k, the true value of d will be given if we divide d by k. So in this case, the unit will move 6 units to the left. And the last variable, c, indicates the shift of upwards or downwards of the graph. In this case, the graph will move 5 units down since it is negative. You can get c by the number outside or at the end of the variable. So, with that being said, we already know our value of the variables a, k, c, and d as we stated on the slideshow before. And now we can implement those variables into number 2 till number 5. So, in number 2, it asks us to write down equation for a transform function assuming the base function of square root of x. It also asks us to explain which transformation affects the domain when comparing the transform function to the base function and illustrate using Desmos. So, simply put, is that the base function is square root of x, and if we implement all the variables that we have collected, we can get a transform function of negative square root of 3x plus 18 minus 5. Now, the domain of the base function of x indicates how far this graph will stretch in the terms of the x-axis. Basically, how long the graph will stretch from left to right. The domain will also be any real numbers. This will be important in a minute. So, the one that will be affecting the domain itself comes from the equation of 3x plus 18, the one that is being square rooted inside of the equation. Now, to do this, we simply going to put it into the equation of greater than 0, since no real number, or basically the graph is going to move to the right. So that's why it's supposed to be greater than 0. After solving for x, we can say that domain will be x is equals to any real number and x is greater than or equal to 6. Now, to do this, we can simply compare it to the link for in Desmos. So, in this link, as you can see, is the base function as the green one. That is, y is equals to square root of x. Now, this will be the transform function that we have. That is y equals to negative square root of 3x plus 18 minus 5. The base function, or basically the origin point from the base function itself, will be at 0.0, as you can see on the graph. But the transform function will be at negative 6 and negative 5. The domain itself will expand to the right. So any number that is greater than 6 is the domain for the transform function. Hence why I say the domain is any real numbers and x will be greater than or equal to negative 6. Okay, so moving back to the PowerPoint. For number 3, we will have to write down another transform function assuming the base function of x squared. This time, it asks us to explain the transformation effect for the range as we compare the transform function to the base function. It also asks us to illustrate it again in Desmos. Now, the transformation function, after we imply all the variables through the base function of x squared, will look something like this. Negative 3x plus 18 squared minus 5. Now, the range of the base function x squared indicates how far does the graph stretch for in the terms of y-axis. Basically, how far the graph will stretch up to down. The range for this one is also could be of any real numbers. The range will be affected by the variable of c, which is basically the vertical shift. Since the graph will be opening downwards, hence the negative value of a at the start of the graph, the range will be y equals to any real number and y is less than or equal to negative 5. We can use this once again to see how this graph changes. So, as you can see over here, the red graph indicates the base function, which is y equals to x squared. And the blue graph, all the way down there, will indicate the transform function, which is negative 3x plus 18 squared minus 5. So, the range basically implements to the point where the graph will curve out on the other way. And from the base function, the vertex, or basically the range of it, will be at 0. But on the transform function, the graphs, or the graph vertex will be at negative 6 and negative 5. And since range is implemented to the y-axis, we can safely say that the graph range will be anything that is less than or equal to negative 5. So, after we cover that, we can move on to number 4. Is it? I think it's, yeah, it is number 4. Okay.